Hi everyone. We're going to analyze the graph of, we'll call this one p to the x, just for fun. So we're going to have x to the fourth plus x squared plus 1 over x squared minus 1. And real quick, this is, the denominator is really x minus 1 times x plus 1, if you factor that. The numerator is going to be p to the x. The denominator is q to the x. Since the degree in the numerator is 4 and the degree in the denominator is 2, we can look at these steps here, and for step 6, that's going to tell us that we have no horizontal or oblique asymptotes because our n is greater than m plus 1. Okay, so that means there's no horizontal or oblique. That means we don't have to determine the points at which the graph intersects, because since we don't have any. It's already in lowest terms. That means, so let's do our domain. Our domain is going to be all real numbers, but x cannot be plus or minus 1. That's because you set this to 0. You cannot divide by 0. It's already in lowest terms. And also, we don't have a hole, therefore. Our vertical asymptotes are going to be x equals 1 and x equals negative 1. Let's do the intercept. We set the numerator equal to 0. We can't factor this, so basically there's no x-intercepts. And for p to the x, we did p to the x. For our y-intercept, we set x to 0. So basically, our x to 0, sorry. So everywhere there's an x, you put 0. So we get positive 1 over negative 1, which equals negative 1. So we do have a y-intercept at 0. When x is 0, y is negative 1. And let's test for symmetry. We're going to plug in negative x everywhere. So we're going to have negative x to the fourth plus negative x squared plus 1 over negative x squared minus 1. And this gives us x to the fourth plus x squared plus 1 over x squared minus 1. Since this looks like our original p to the x, it means p to the x is symmetric to the y-axis. So this equals our original equation. So it is symmetric. That's going to help us graph. It's already in lowest terms. The next thing we're going to do, and we don't have to determine if it crosses the asymptotes, the horizontal or oblique, because we don't have horizontal or oblique. So I'm going to use my interval here. I'm going to pick intervals at negative infinity to negative 1, negative 1 to 1, and 1 to infinity. And this is because my vertical asymptotes were at negative 1 and 1. And I want to determine how the graph behaves from negative infinity to 1, what's going on from negative 1 to 1, and I want to know what's going on from 1 to infinity. So basically, I got 3 intervals here I have to check out, and I'm going to pick some points on these intervals. I pick as close to negative 1 as I can. I always pick 0 if I can, and I'm going to pick 2. And I try to pick points without fractions in them. And then we have to, so that's my x values, and I need to find my y values. So I'm going to evaluate p of negative 2, p of 0, and p of 2. And I get negative 2 is going to be 7. 0 is negative 1. That's your y-intercept. And p of 2 is 7. Which makes sense because this is symmetric to the y-axis. And then I'm just going to write down my points, my x and my y. The points on the graph would be negative 2, 7. Just picking this. 0, negative 1. And 2, 7. And I'm going to graph this. And I have my x-intercepts. My vertical asymptotes, my lines, at x equals negative 1 and x equals 1. Okay, so this is x equals 1. There's no horizontal or oblique. And I'm just going to plot my points. So it looks kind of like, and like I said, you can use your calculator on this. Negative 2 goes to 7. Let's see if this is 7. 1, 2, 3, 4, 5, 6, 7. And 2 also goes to 7, maps to 7. So it's something like this. That never can cross. I'm doing the best I can here on the iPad. And then for my intervals, so I had my 3 intervals. Here's my interval here. I have an interval here and one here. And my other one, I have a y-intercept at negative 0, negative 1, which is below the graph, and it goes like this. It never crosses. Okay, that was my 0, negative 1. These points were 0, 2, 7, and negative 2, 7. Okay? That's all. Thank you and have a nice day. Bye-bye.